Hello everybody and welcome back. In the previous video, we have seen how to write the code for creating a sequence of running LEDs, and in this video, we will see how to create a sequence of running LEDs in alternating directions. Now, what do we mean by this? So in the previous video, we saw that the LEDs were turning on in this order 1, 2, 3, 4, and again it starts from 1, 2, 3, 4. So once we reached the last LED, we were starting from the first one again. Now here we want to also go in the opposite direction. That means it will go like 1, 2, 3, 4, and once it reaches 4, it will again go back to 3, 2, 1. And again 1, 2, 3, 4, then again 4, 3, 2, 1. So it will go in both the directions. So we will see how to modify our code or write the complete code in order to achieve this sequence. So again, if this is the first video that you are watching in this playlist, and if you want to learn how to make these connections, I encourage you to watch the video in this playlist, which is blinking 4 external LEDs on the Raspberry Pi Pico, where we have discussed how to create these connections. So I will not repeat how to make the connections again in this video. Alright, so let's go to the coding part. Alright, so coming to the code, let me explain the lines of the code one by one. First of all, we are declaring a constant integer called num_LEDs, which is initialized to 4, which represents the number of LEDs that we have. And secondly, here we have a constant integer array called GPIO pins, and the elements of the array are 0, 1, 2, and 3, which represents the pins to which the LEDs are connected. So here we can see the LEDs are connected to pin numbers 0, 1, 2, and 3, which are the GP pins. And then we are declaring another constant integer called run rate, which is initialized to 500. And this one represents the delay that we want to give between the LEDs. And here I am also defining a static Boolean variable called direction, which is initialized to 1. Now, what is this used for? We will see as we move ahead. So remember that direction is now equal to 1. It is a Boolean variable, which means it can toggle between 0 and 1. So initially it is set to 1. Alright, now coming to the setup function. In the setup function, we want to initialize all our GP pins or the LEDs as output. So we are running a loop here using the variable LED, which will start from 0 and go till it is less than num LEDs, and it will keep incrementing. And here we say pin mode GPIO pins of LED output. That means LED will take the values from 0 to 3, 0, 1, 2, 3. Because num LEDs is equal to 4, and this loop will run from 0 to 3 because the condition is less than, not less than or equal to. And each time it comes here, it is going to represent this array GPIO pins, and LED will go from 0 to 3. So GPIO pin of 0, 1, 2, and 3. So GPIO pin of 0 is LED number 0 or the pin number 0, and GPIO pins of 1 is the first GPIO pin. So it is going to represent each of the GPIO pins to which the LED is connected, and we are setting all of them as output. So using the for loop, we have set all of them as output. Okay, so the initialization of our pins is done, and next we are coming to the void loop function. And here, as you can see, I am calling a function called running LEDs, which was a function that we have also seen in the previous video, but previously it had only one parameter. But here we are passing two parameters to the running LEDs function, which is run rate and direction. Now, what does this running LEDs function do? We will see below. And also see that here we are also saying direction equal to not of direction. That means whatever is the value of direction, it will be negated. So if it is 1, it will turn to 0. If it is 0, it will turn to 1. Okay, now let's come to the definition of the running LEDs function. So look at this running LEDs. The return type is void, so it will not return anything. And the parameters are one integer, which is run rate, and one Boolean, which is direction. So what is run rate? Run rate is the delay that we want to have, which is given as 500 here. And what is direction? Direction is initially set to 1, so it is equal to 1. So run rate 500 and direction 1 is passed. Now it says if direction equal to 1. That means if the value of direction is equal to 1, then we are running a loop here again using the integer LED, and it is going to run from 0 till it is less than num LEDs. and we'll keep incrementing, and it will come here and say digital write GPIO pins of LED high. That means in the first iteration, LED is equal to 0. So GPIO pins of 0, which is the first LED, will be turned on. And then we are giving a delay of run rate. Run rate is equal to 500 milliseconds. So we are giving a delay of 500 milliseconds. Then we are turning the LED off. That same LED will be turned off or low. And again, the same delay is given. Okay, so this loop will run for all the LEDs from 0 till 3. 0, 1, 2, 3. 0, 1, 2, 3. And at each time, the LEDs will be turned on and they will be turned off. So in the first iteration, this will turn on and it will turn off. Then second one will turn on and turn off. And then third one will turn on and off. And fourth one will turn on and off. So one sequence is done. Now we have to come back. We have to run it in the alternating sequence. For that, we come to the else part. Okay, now how will it come to the else part? So first of all, once this loop is done, once the condition of this loop fails, it will break from the loop and it will not go to the else part, because we came to this loop because this if condition was true. So it will not go to the else part. So once this loop runs, it is going to go back to where this function was called. And where is it? It was called from the void loop function here. So in the void loop function, we see that the function was called here. So it will come back here. And the next line in this code is direction equal to not of direction. So remember, direction was set to 1 initially. So that will now be set to 0. So now direction becomes 0. And then what happens? Here we see that this is inside the void loop function. And what does void loop function do? It is going to run the code again and again. So this code will run again. That means this running LEDs will be called again, passing run rate, which is 500 milliseconds, and direction, which is now equal to 0. So remember, since we have set direction equal to not of direction, direction is now equal to 0. So 0 will be passed now. So now at this time, when it calls the function, it comes to this running LEDs function and it checks if direction equal to 1. So this condition is false because direction is now equal to 0. So at that time, where will it go? It will go to the else part. Now what have we written in the else part? In the else part, we can see that we are running a loop again, but this time notice that we are starting the loop from num LEDs minus 1. So LED equal to num LEDs minus 1. LED is the integer that we are going to iterate over the loop, and it is initialized to num LEDs minus 1. What is num LEDs? It is 4. Minus 1 will become 3. So LED is equal to 3. And the condition is LED greater than or equal to 0? Condition is true. And then after it runs this, there will be a decrement here, LED minus minus. Okay, so here LED is now equal to 3. So what will it do here? Digital write GPIO pins of LED. That means GPIO pins of 3 will be set to high. Now what is GPIO pins of 3? GPIO pins of 3 represents the third index in the array, which is this 0, 1, 2, 3. So it is this one, the third index. So remember, array indexing always starts from 0. So it is this element that we are referring to. That means GPIO pin number 3. So it is this one. The last LED will turn on. And what happens? Then we will give a delay of run rate and it is going to again be set to low. That means it will turn on for 500 milliseconds. Then it will turn off for 500 milliseconds because here there is again a delay of run rate. Okay, and in the next iteration of the loop, what happens? LED minus minus. LED is decremented. So what was 3 here becomes 2. So what is the condition to be checked? Is 2 greater than or equal to 0? Condition is true. So what will happen? It will come here and say GPIO pins of 2 is set to high. What is GPIO pins of 2? This is 0, 1, 2. That means it is this LED. So this one, this pin, that means this LED. Okay, so this LED will be turned on for 500 milliseconds and turned off for 500 milliseconds. So similarly, it is going to happen for this LED and this one as well, as a decrement happens. And once this condition becomes false, it will break from the loop, and where will it go? It will go back to the place where this function was called. And where is that? It is here. Okay, and once it comes here, what will happen? The next line is direction equal to not of direction. So direction was equal to 0 if you remember. So not of 0 means it will become 1 now. So direction is now set to 1, and since this is inside void loop, it will run again. So again this running LEDs will be called, and at this time what will be passed? Run rate 500 and direction is now equal to 1. So it will come here and check the condition. If direction equal to 1, true. So this loop will run where all the LEDs in this order, that means 0, 1, 2, 3 will be set to high and low, and then again this will break from the loop and come here again, and again not of direction will happen. And when not of direction happens, what happens? Again, once this function is called again, it will come to the else part and it will start turning on from this side. Okay, so it is always going to go from 1, 2, 3, 4 and 4, 3, 2, 1, and this sequence is going to continue repeatedly. Okay, so let's run the code and see if it is working as expected. So you can see 2, 3, 4 and then 4, 3, 2, 1, and again 1, 2, 3, 4 and 4, 3, 2, 1. So we can see it is working as expected. Now let me reduce a delay here. Let me say that I want to give 100 milliseconds delay, and let's see what will happen now. It will go a little faster. Okay, now you see that once we reduce the delay, it is going faster. Okay, now you can also play around with this code and see how you can modify things and make it work differently as you like. And also if you want, you can remove the delay from this low part like we did in the previous example, so that it will again look a little faster. So as you can see, once it turns on and when it goes off, there is no delay. The second one is turning on instantly. So you can see that you can create multiple sequences like this and play around with it and learn more about this. So I hope this is bringing some interest in you in programming the Raspberry Pi Pico. And there are many projects that you can do with this, but we will mainly work with LEDs and we will see what are the various things that we can achieve using these LEDs and through the codes that we write. So I hope this lecture about how to create a sequence of running LEDs in alternating directions is clear to you. Thank you for watching and see you in the next one.